Hey everyone, welcome in. John here, staff software engineer, 10 plus years of experience, and let's work on product of array except self. You can see I worked on this earlier today and I was able to get an optimal solution, and that was after looking at the solution. So took some time away from the keyboard, went out, got lunch, now we're back, and the question is, can I recall it and how quickly can I execute it? So in the previous session when I got a brute force answer and then I tried to refactor to an optimal answer, so I had the right idea, wrong syntax kind of situation. That performance period was a 45-minute work bout, and we want to get that down under 30, ideally under 20 minutes when you really got the problem down. So this is going to be a hardening, sharpening, and kind of like a recall exercise, okay? Laterally is a free and open source platform that I maintain. You can sign up for free, land your first or next programming role, and grow your professional network. There's a Discord under the community drop down with hundreds of other engineers over there. Would love to see you there. So with that, let's dive into the problem. Product of array except self. This is a median, and the prompt reads, given an integer array called nums, let's return an answer array such that the ith element of answer is equal to the product of all of the other elements in nums except itself. We're guaranteed that the prefix and suffix will fit in a 32-bit integer, and we should write an algorithm that runs an O of n time complexity without using the division operator. And this is basically the reason that it's a medium instead of an easy. If you were allowed to use division, you could take all of the numbers in nums, multiply them together, and then just iterate through and divide by the current number to get the product of all the other numbers. Does that make sense? But because we can't use the division operation, we need to think of some other algorithm that gives us the equivalent data. And the way you can do that is if you get the product of the items to the left and the product of the items to the right and multiply them, you've effectively gotten the whole thing with the middle divided out, but you never needed to use the division operator. So that's what we're going to try to do. And the initial way to do this is to construct a left products array, a right products array, and then iterate through the left products array, multiplying by the right products array and assign to the answer. You can do better still, see the follow-up question, can you solve an O of 1 extra space complexity? Extra meaning other than the returned array. So it's really going to be O of n space complexity, but constant other than the return. And the way you do that is you don't construct the left and right arrays. Instead, you just construct the answer array, fill it with the left, and then iterate backwards on itself. So it acts as the left, right, and answer in that one array. So it's a linearly better space complexity, but that is the optimal solution. So let's see if we can do that. The other approach, you can see my live streams on YouTube. These are saved to YouTube. The other approach where you do left, right, answer as 3 distinct lists, I already did that, so I don't consider that too challenging. I'm going to be trying to go right for the optimal solution where we build left to right and then we repeat back on itself to form the answer array in a 2-pass on a single data structure. Does that make sense? Let's get into it. Thanks for being here. Consider liking the video so the algorithm will send it around. Antonio on TikTok says, do left and right pass. Exactly. That's what we're going to try to do. A left and right pass on a single output array as opposed to multiple data structures, right? Good call. Let's see if we can get that in. Okay, so I'll call this answer. It's an empty list. We'll eventually return answer. And then what we want to do is for I in range length of nums, we want to populate left to right in first pass with, and I'm going to call these prefix products. So this pattern is often called prefix sums, but we are multiplying, so I'm going to call them prefix products. And then here I'll have populate right to left by, or not really populate, but update right to left by multiplying suffix products. okay? And here we can do for I in range length of nums. So it's the same length, but we want to go end to beginning, okay? So I'm going to go -1 is the first element that we want to see. When you're iterating from 0 to the length, the last one will be n minus 1. So it's the whole off by 1 thing in programming. So similarly, if you want to start at the end, you want the index, which is the length of it minus 1. Okay? And the terminal index will be 0, and we will proceed in steps of -1. If that's hard for you to remember, it's hard for me to remember too. Another thing you could do here is like range, like reversed. You could do reversed nums is another thing you could do, which is maybe easier to remember. Okay? All right, so this is the outer structure. There's an edge case here at the very first element, at the first index, when your index is 0. How do I get the product of the elements to the left of that one? Because it's out of bounds to the left, right? Well, we're going to use the value of 1 because it doesn't disrupt our result. So we want to get the product of all the elements except self. And if we multiply that by an extra 1, it doesn't hurt anything. So that's a way that we can basically pad the borders and still get our desired result, is multiplying by 1. And this is where that math aspect of the problem comes in. So this will cover multiple patterns. Obviously, arrays, integers, and also math is an element of this pattern. So I'll say if I is 0, answer.append. And so we're appending in this first pass because we're building up the answer array. So I'll append 1. Else, I want to take whatever it was previously and accumulate it. So answer I minus 1 times nums I minus 1. I think that's correct. So that should give us the cumulative value of the products 1 to the left of where I currently am. I think that's right. Okay, so here we have built up the left to right, and let's go ahead and just check. So 1, 1, 2, 6. Good, that's what I expect. In this case, 1 for the outer one, then 1 for the product of the elements to the left of the 2. That will be another one. Product of the elements to the left of the 3. That's a 2. Product of the elements to the left of the 4. That's a 6. So we've got the right math here. Make sense? All right, we're cooking. Let's keep cooking. So now I'm just going to print I just to make sure that I have the range syntax correct before I get too deep. So what am I expecting to see here is literally just 3, 2, 1, 0. 3, 2, 1, 0. Ah, I didn't get the 0. Why did I not get the 0? Three, 2, 1, 0. Okay. Works for me. So now we're iterating right to left on the indices 3, 2, 1, 0. Now that I'm going right to left, I want to similarly do this boundary check if I'm the first element. So if I is the first element right to left is what? Length of nums minus 1. Then I could just pass. Because what I want to do is multiply it by 1 right to left. So I could just pass. But let's go ahead and multiply it by 1. I want to say right, left, else, right, left are going to have different values, and in either case, answer, the I index of answer is equal to right times left. That's what we're going for, right? That's the product of the elements except self. It's right times left, and I'm going to assign that where I currently am. Okay, so in this edge case, the right will set it equal to 1, and the left will be, this is the tricky part. What is the left? The left product is the current value because we populated it when we came left to right. So the left product is just answer, the I index of answer. Okay, and that will still be true in this else case. But here, what is the right value? What is the right value? I need to accumulate it. I need to accumulate it separately. So here I will say accumulated right. And that's going to initialize at 1. How do you spell accumulated? Cumulative right. That's easier to spell. Cumulative right. So it's initially 1, and now we need to update that. We are accumulating right to left on nums. We're accumulating right to left on nums. So we should multiply by nums the I index. The I index. So in the first case, this will be 4, and then it will be 12, and then it will be 24, and then we'll have gotten here, and we'll do 24 times 1. That's the output I expect, right? Okay, so it looks good. So it looks good. And so then here, that's also the case here, isn't it? Let's check. Good. So this works, and actually I don't need the conditional at all in that case, because they are going to be identical assignment expressions. And this is the final solution that I expect. And we're at the 13-minute mark. Bingo. That was interview worthy, wasn't it? Cool. It really speaks to the trade-off when you are planning initially. You're using the engineering method and planning different options and thinking through their time and space complexity. If I had gone to the option of right, left, and answer array, the 3 different versions, and if I had solved it, I could have probably solved it in about the same time. But then refactoring it into the current, more optimal solution would take an extra couple minutes, wouldn't it? So it's a little bit of a gamble. Ellie says, nice work. Thank you, Eli. Is it Eli or Ellie? I guess it's Eli. Thank you, Eli. So you are weighing these trade-offs. It's a little bit of a gamble to go straight for the more difficult solution. The good news is, if you're practicing like this, I could have gone for the brute force and refactored still within that 17 to 20 minute mark that we're shooting for, because I got this solution in 13 minutes, and I think that refactor is like a 2 or 3 minute operation. Does that make sense? So honestly, if I were in an interview, I probably would not jump straight to this. Probably would not jump straight to this. And that way I can kind of, it does 2 things. 1, I can have an insurance policy. If I fail to get the optimal solution, at least I have a working solution. So it's kind of an insurance policy. And 2, it's almost a flex if you're able to get a brute force coded and then refactor it in time. It's almost a flex because now you've like done the work of 1.5 or 2 problems. So it's a gamble either way. I'm not saying there's right or wrong. If you see an interview question, you feel like I can really go to optimal straight out, it's kind of up to your risk appetite. That could be the right thing to do. I saw this problem earlier today, so it's kind of fresh in my mind. If this was 6 months out since I've seen the problem, I would be really hesitant to go right for the optimal thing. I would probably speak that I know there's this optimal solution, but let me code the brute force first. Okay, so that's going to do it for the current stream. I hope you'll follow the page, and I'll see you next time. Thanks for